Hi, welcome to this video on the essential concept of logarithms. About 400 years ago or so, in the 1600s, advances in the sciences and in mathematics had led many people to situations where considerable calculations had to be undertaken. Remember, calculators had not been invented, and even tools such as the abacus were too slow. The abacus had actually first appeared way before, in the Mesopotamian period, about 2500 BC. But in the 1600s, an English mathematician, John Napier, was attracted to the fields of inquiry where calculations made by investigators were becoming increasingly more complex. Napier approached the problem of making these calculations simpler from the viewpoint of trigonometry, but he also used other viewpoints as well. One approach taken by Napier sought to reduce quantitative measures based on a wide scale of numbers to a more limited scale. Examples of the measurements Napier examined included, firstly, decibels used to measure sound intensity, and secondly, the acidity of an aqueous solution. Many years later, other researchers used a similar goal of making calculations simpler and the interpretation of data more straightforward when they examined the tremendous forces exerted by tectonic plates in producing earthquakes. Napier considered addition and multiplication as being fundamental arithmetic operations which can be undone or reversed by, respectively, subtraction and division. For example, the operation of 3 plus 4 equals 7 can be undone or reversed by 7 minus 4 equals 3. The operation of 3 times 4 equals 12 can be undone or reversed by 12 divided by 4 equals 3. Napier wanted to extend this idea of reversibility of operations and therefore sought to analyse the operation of raising a number to a power. For example, 2 cubed, 2 to the 3, is equal to 8 because 2 times 2 times 2 equals 8. To describe the index in equations or expressions, and therefore introduce the idea of reversibility, Napier developed the idea that the index, here 3, could be called a logarithm, and that the logarithm of 8 is 3 with respect to the base of 2. Expressed more generally, Napier considered that the logarithm of a real positive number x with respect to the base m is the exponent or index n to which the base m must be raised to obtain x. So if we write x equals m to the n, we capture Napier's idea. In other words, the logarithm of x to the base m is n. We can write this statement as, you can see the bit in red, log x to the base m equals n, or we could say the log base b of x. Probably the first one of those is better, but don't read the words and letters in a line. In other words, do not say log mx. It's better to say log of x to the base m. It is important to appreciate that the logarithm of a number changes with the base chosen. Earlier we noted that 2 cubed equals 8. Now if we change the base of 2 to become a base of 5, then the index or the logarithm changes to 1.2920. So now 5 to the 1.2920 is equal to 8 approximately, to about 5 or 6 decimal places, or the logarithm of 8 to the base 5 equals 1.2920. It is very important for you to be able to change between the two formats quickly and accurately. So in other words, to be able to change from the exponential format to the logarithmic format. You're going to do it many times, so get good quickly. If we are given 2 cubed equals 8, the way to change from this exponential form to the logarithmic form is write log, L-O-G, in front of the number by itself, so in front of the 8. Take the base from the left-hand side and write it as a subscript to the log on the right-hand side, so the 2 goes underneath. Thirdly, let the base fall down into place, so the 3 falls down to be the same level as the log. If we look at this in slow motion, we can see the steps being repeated. We can easily move in the reverse direction from the logarithmic format to the exponential format as follows. We have 3 equals log 8 to the base 2. We move the 2 from the subscript across to the left-hand side, and that pushes the 3 upstairs. And then we remove the word log, and so we have 2 cubed equals 8. Logarithms can be positive or negative. We have seen that if we wrote 8 equals 2 cubed, then log 8 to the base 2 is equal to 3, which is positive. But if we have the fraction a half, we could rewrite this as 2 to the minus 1. So a half equals 2 to the minus 1. We change from our exponential format to our logarithmic format by writing log in front of the half and bringing the base from the right-hand side to a subscript under the log. So we have log of a half to the base 2 equals the index previously minus 1, just simply drops down into place. So minus 1 is a negative, which shows that logarithms can be also negative, not just positive. In our general work, we have to be able to change from the logarithmic form to the exponential form to simplify or to evaluate certain expressions. We have to do this really carefully and very quickly because we do it so often. As an example of what I'm asking here is evaluate log 64 to the base 4. Well, our strategy is to let log 64 to the base 4 equal x. So, unpacking our logarithm, we have 64 equals 4 to the x, with the 4 coming across and pushing the x up into the air. 64 is 4 cubed, so we can now write 4 cubed equals 4x. So equating the indices, we have x equals 3. As a second example, we might have to evaluate log of the square root of 2 to the base 2. Well, strategy is exactly the same. We let log square root of 2 to the base 2 equal x. We change the root 2 to a 2 to the half, so that we're using our index form there. We then unpack our logarithm, so 2 to the half is equal to 2 to the x, with the base coming across from the left to the right and pushing the x into the air. So we then equate our indices and we say x equals a half. Easy. In summary, a logarithm is the exponent or index to which a base number must be raised to obtain a given value. So if we have a base of m and we want to create the number x by using the exponent n, we can simply write m to the n equals x. Then converting that into logarithmic form from the exponential form we have now, we can write n is equal to log of x to the base m. So there is an introduction to the essential concepts of logarithms, with examples of moving from the exponential form to the log form and back again. So go now and do some or all of the exercises in Test Yourself 1 to evaluate your understanding. Make sure you feel really confident with changing from one form to another. Good luck, and remember, being a log can be very enjoyable too. Bye-bye.